Hello, welcome to the second part of this Minesweeper series. So in the first episode we created our basic project and we can render a board for our Minesweeper, and it's showing the content for each of the cells. So this time we need to actually load the board with some proper state for a game. So since the last video I haven't written any code. What I have done is I've tidied up these folder structure. So I've moved the code into a subfolder called source. I've added in our sample game picture, which we've been using. So this is what we're going to load, is that sort of board in. And I've also created that as a text file where it represents a number of mines as represented as numbers, and spaces represent unknown cells, and this is our 8x8 grid. So before we do anything else at all, I want to add what we've done so far into GitHub into my account. And so we can go into our command prompt and follow the commands, which is git init. I'd already copied in the git ignore, so that's going to prevent things like obj and bin files being added, which we don't want. We can add in everything else, so we can check using git status, which is fine. So that was part 1, and we can push that up. Oh, let's set the remote first. And once that's completed, if we refresh our page, we now have our source code, which is great. Okay, so before we start passing this file, we need to be able to pass the initial state of our game into our game object. So we never want our game object to be in an invalid sort of state, so we need to set this in the constructor really. So what we need to do is pass in the cells which contain a mine count. So a cell can either be an unknown, or it's going to contain an integer. So it's going to be a two-dimensional array but it can also be empty. And then once we've been given that initial state, we can then compute for ourselves how wide the board is and how high it is. So unlike the UI bit we looked at in the last video, we couldn't really test that, but this back-end code, the more sort of the logic, we can actually test. So let's add a second project containing some unit tests. So I tend to use xunit. So you can go in our folder. So we've got a subfolder called tests. Okay, so we can add a dependency to the code we're trying to test, and we're checking we're really checking the initial state of the game. There's obviously various different ways you can structure your tests and name them and so on. In this case, we're only going to have a handful of tests in total, I think, so I don't think we need to be too particular. So we can just say check the width and height are correctly calculated. So there are 3 rows, no, 3 columns, 4 rows. So we're given our initial array, and it's going to simply calculate our rows and columns. We'll do for our first test. Oh, not sure I managed that. It's better. What I meant to do was that. And they can be private because we only want to set them within our method. I'd like to put my properties first. So we need to make sure we've got a failing test. So I'll just do it there. Okay. Okay, I'll do it from there then. Okay, so that's in here, isn't it? We need to set something in there. Okay, so our tests are failing at the moment, as we expect, so we haven't actually put any code in. So they're returning 0, which is their default values. So the code will be as simple as so that gives the highest index you can access, so the size of A is actually one more than that. And we need to do it in the second dimension. Okay, that's much better. So our next test is actually we can actually load the cell count. So the mine count. So we just pick a couple of locations. Let's do 1,2 should equal an 8 and 2,3 1. Okay, just check that's failing. $21. Oh yeah, because we're returning some weird numbers. Yes. Right. So the state we're going to hold internally, we can still represent as integers. We've got a couple of other cases, such as the cell could contain a mine, or it could be proved to be an empty cell, but we can use negative numbers to represent them in a minute. So we just need a private variable. I don't really like it being nullable, so I think we should try and get away from that. I think there might be a clever way of doing it, but for now I think we can just loop over all the cells in order to populate it. So the reason we need to do that is we need to replace our null values with something else. Otherwise, it'd be quite straightforward. So this won't work because that can be null. So in the case it is null, we want to say it's an empty cell. No, we don't. We want to say it's an unknown cell. So we need a constant to represent unknown cells. And it can be any negative number, so -1 is as good as anything. And when we return the cell contents, so actually if it's unknown, it's going to be empty. So any other cell should be empty. So we just need to switch over the cell content. When it's a unknown cell, we can return a space. Anything else, we're going to return its contents as a string. Space. Do you want a space or just nothing? Maybe just nothing. Okay, that's passed. So now we can actually load our board or our initial state from a file. So we don't want to do that within the game object. This is going to be another object. I think we can call load game from a file. This will have a single method which returns a game and takes in its file name. You can be asynchronous. So we're going to read all our lines in for our file name. So it gives us an array of lines. So we know number of rows equals lines.count, or length, and the number of columns is the width of any line, so makes sense to the first one. And our convention is we're doing columns and rows everywhere, switch those around. So now we can create an array to hold our state. Now we can populate that array just by looping over the lines we've loaded. So we have to do it as a no, it's quite straightforward. So our cell is, we have to pick the right line first, so the line is based on the row, and then within the line we just want to pull out our column. So that gives us a char. So if it's not empty, we can then say the initial state of row, comma, column, nope, column, comma, row is and finally, so once we load the board, we can then return a new game with that as its state. I think because we're including this file in the project, we can probably add a test for it as well. Probably should have done this first, but load games from files. Right. Check we. Okay, so we expect it to be 8,8, and we can also check a couple of our cell contents. So looking at our diagram, 0,0 should be 0. 1,0 should be blank, and let's pick 1,2. So 1,2 should be a 3. Is that broken? Oh right, no, I think that's passed, isn't it? Okay, so we just need to hook that up now. So in here, instead of creating a game like that, we need to say game loader is new. Now, because we're calling it in the constructor, we can't use an asynchronous method. Okay. Well, that's gone very wrong. We still got the number of rows hard-coded in here, that's right. So we had them hard-coded as 8 and 10 before, but they need to come from our game object now we've calculated them. That's looking a lot better. So let's compare that to our image. That's looking 3, 1, 3, 3, 4, 2, 1, 3, 3, 2, 0, 1, 1, 2. That's looking good. So in the next episode, we will start solving the board. Thank you for watching.